All right, hello, you guys. Let me check really quick the mic's on. It is. Perfect. All right, we're on lesson three, more about constants of proportionality. In our last lesson, we were talking about um, how a table is proportional and how there's a constant of proportionality. We're going to continue solving more problems involving proportional relationships using these tables. We're going to be identifying constants of proportionality. That's the bell on my cat's collar, if you can hear it. So we're on activity one, centimeters and millimeters on page 121. So we see here, there is a proportional relationship between any length measured in centimeters and the same length measured in millimeters. We see centimeters and millimeters. There's actually two ways to think about this proportional relationship, and we're about to do two of them. Okay, so let's just think about this one. From centimeters to millimeters, how do we get from 1 to 10? How do we get from 2 to 20, 3 to 30, 4 to 40, 5 to 50? This is literally, wow, I never realized this, but this ruler is actually a double number line. It starts at 0, and each one of these is a pair. And you could already see that, hey, we are multiplying by 10 on each one of these. So the constant of proportionality is 10. It's 10 on this one. And you could easily figure it out too with the unit rate. How much for one? How much for one of something? And you could see that, hey, it was 10. Oh, wow, that lag. There you go. Oh, it was 10 times 10. So what is the constant of proportionality? Well, I'm gonna use one of my sentence frames to just say this to practice. The constant of proportionality between the centimeters and millimeters is 10 because we are multiplying by 10. That's what you guys are gonna do in class. Yeah, you don't have to write this down, by the way. Don't write that down. It's just for me to help you guys with instructions. Okay, so let's look at number one on page 122. If the length of something in centimeters is known, its length in millimeters can be calculated. I put the ruler here just to help you guys out. We mentioned before that we have centimeters and millimeters. We're going from centimeters to millimeters. And as you can see, if we are going from centimeters to millimeters, we are multiplying by 10 times 10 times 10 times 10. So that means that on our table, you're going to be multiplying by 10 because that is your constant of proportionality. Do, do, do. There you go. 9 times 10, 90. 12.5 times 10. You can always move it one decimal place to the right. That's literally multiplying by 10. 125. If you don't believe it, you could also do like the 90, the decimals right there. One to the left, and you add a 0, like that. So same thing here, times 10. You move it once here, and it's 500. You move it once to the right, one times 10, and you have 800, oh, 884.9. There you go. So for this table, we have a constant of proportionality of 10. It's multiplying by 10. And we know that because we could see that here on our ruler. Our unit rate was 110, and that's literally the same as the constant of proportionality. Now, we're about to see a second constant of proportionality using these same measurements. But this time we're going to use the reciprocal for it because we're going to need to flip it. And if you don't remember, if you have 2 over 5, the reciprocal of it is just flip. 5 over 2, you just flip the numbers around. That's all. Same thing, 12 over 1, you just flip it. Flip it around. Yeah. Okay, so still on page 122, we there's a slight change now. We are now going from millimeters. The length of something in millimeters is known. Its length in centimeters can be calculated if we know the millimeters. Yes. So now instead of going from centimeters to millimeters now, we are now going from millimeters to centimeters. Here on our table, millimeters to centimeters. Now, before it was times 10, but now you need to do the reciprocal. The reciprocal of times 10, 10 over 1. If we do the reciprocal, reciprocal, times 1 over 10. You flip it around, so it's times 1/10. I'll write on this side, it's a little small right there. Times 1/10, because you're going the opposite direction. So times 1/10, times 1/10, times 1/10, and times 1/10 for each and every one of these. Yes, you can think about it as you're dividing by 10, but remember, constants of proportionality are multiplying numbers. We're multiplying by it. So we're thinking about it as a fraction times 1/10. So we have 70 times 1/10, that is 7. 245 times 1 over 10. Just like you're dividing, multiplying by 10, you would move, if you're multiplying by 10, you would move it on this direction to make it bigger. But if you're multiplying by 1/10, it's actually getting smaller. So we move it once to the right, to the 110 value. There you go. 24.5. Same thing here. Move it one to the right. So you have zero point 0.4 or 0.4. I like putting the 0. Same thing here. 69.91. So we have the same measurement still, but we flip them around. But we flip them around. We flipped them around. So it changed our constant proportionality on this table to a reciprocal version of our original times 10. So the constant of proportionality for this table is 1/10. So the units matter for this one. Yes, this is dividing by 10. Oops. Yeah, it's dividing by 10. There you go. Oops. Let's continue number 3. Now, how are these two constants of proportionality related to each other? The two constants of proportionality are related because one was times 10 and the other one was 1 over 10. Well, they are both reciprocal. They are flipped slash reciprocals of each other. Yeah, they are flipped reciprocals of each other. So they are not the same. Absolutely not. They're not the same. But because of our table and how it was set up, I believe this one was centimeters to millimeters. Yeah. And then this was millimeters to centimeters. It does change based on what our table is looking for, or what our table looks like. So when we are converting from centimeters to meters, the value in centimeters is multiplied by 10. Here, times 10. To convert from millimeters to centimeters, the value in millimeters is divided by, yes, this is also divided by 10. It's divided by 10, or multiplied by 1/10. There you go. All because our table made a difference in how we wanted to look at our units. So yeah, sometimes you could have the reciprocal version of a constant of proportionality depending on what your table's giving you. So key takeaways here. The two constants of proportionality are reciprocals of each other. Yeah. Awesome, awesome. We have activity 2, Pittsburgh to Phoenix. Let's see. Let me skip this part. We're just going to go for... Where's the map? There it is. Okay. On its way from New York to San Diego, a plane flew over Pittsburgh, St. Louis, Albuquerque, and Phoenix, traveling at a constant speed. So it traveled all those things at a constant speed. So this means that it traveled the same speed all the way across each one of these. This just means it's proportional. It's proportional. That means there is going to be a constant of proportionality right there. So let me skip over to over here. Yes, perfect. All right. So just by looking here, we have the time of how long it took and the distance that they went. Just by looking here, you can already see that this is the unit rate. How much distance for 1 hour? That is literally the same as the constant of proportionality. So the speed is 500 miles per, oops, per 1 hour, or just per hour. I'll write per hour. There you go, per hour. And even though these are different boxes here, realize that they did mention that they went a constant speed, the same speed in each distance right here. And you can tell that from St. Louis to Albuquerque, they still went the same distance. So every single one of these has the same exact speed. The same exact speed. We could figure out what is the distance. What is the distance between St. Louis and Albuquerque? If you're looking at this and going, what are we doing right now? Like, how do you even do this? Well, think about it as a double number line. I'm literally just putting the information we have. We have 550 miles in 1 hour right here. This here, notice that it's in minutes also. Let's turn this into, so if you divide it by 60, you get 0.7. So this is 1.7 hours. 1 hour, 0.7. Yeah, 1.7 hours. Yeah, there you go. Yeah, so that's where we have, so 1.7 hours and this missing hour go here, and the 330 go here. I just made a double number line right there. One's distance and one is time. And I want you to realize that the information we got here, the 1 hour and 550 miles in the first box up here, I want you to realize, how do we get from time to this? How do we get from 1 to 550? Remember, there is a constant of proportionality. We need to multiply by something. Luckily, it is a unit rate. So we know immediately, hey, it's times 550. It's the same. So it's the exact same thing times 550. And if we know that this whole table is proportional, oh, not 500, 550 times 5. Why do I keep writing 500? I really like the number 500. Yes. So we're still using the same unit rate or constant of proportionality. So all we're doing is literally multiplying by 550. So I'm gonna use my handy dandy calculator. So 550, I'm using it by hand, by the way, times 1.7 is 935. So let me zoom out. So from St. Louis to Albuquerque, we have 935. And we literally said that, hey, it's going to be the constant of proportionality times the time is going to equal our distance. So just by looking right here, remember, we're going upwards, so times 550. So we have a situation here where we know how many miles it is, but we don't know how many hours it is. Like, we don't know. Like, we don't know at all. Oh, what is the distance from St. Louis? 935. There you go. Now it says for number 2, how many minutes did it take to fly from Albuquerque and Phoenix? It says minutes, so we have to turn that into minutes because it's going to be in hours. We'll think about that later. Okay, but first things first. If we want to go backwards, we have to do the reciprocal of times 550, which is actually multiplying by 1 over 550 if we want to go the opposite direction and find how many hours. So, or you could think about it as dividing by 550. So 330 divided by 550 is 0.6 hours. I don't know why I made it in that color. Orange it is. Beautiful. 0.6 hours. There you go. But we do want it in minutes because I think that's what the question said. Yeah, 1 minute. So 60 minutes in 1 hour. So it's going to be times 60. So times 60. No, that's not correct. 0.6 times 60. That equals 36 minutes. Yeah, 36 minutes. If you're wondering why are you writing minutes, the question, it is actually 0.6 hours, but the question wants it in minutes. So we did multiply it by 60 to get minutes. There you go, minutes. Yeah. So this does in fact equal, let me turn this black right there, perfect. And 36 minutes, and this was 935 miles. So you could see that we're using the unit rate the exact same way to find this table. So 550, 1.7 times 550, the unit rate or the constant of proportionality is 935. Same thing with this and this, because they are all, what do you call them? Equivalent ratios. Equivalent ratios, yes. All right. So we have this table. Here's another way you could have done it. You could have also done equivalent ratios, yeah, with a variable and just cross multiplied, and you would have found the same exact thing, 935. Multiply these two, you get it. Multiply these two and these two, and then all you do is divide both sides, and you get the same answers. Yeah, two different methods. Enjoy. So what is the proportional relationship represented by this table? Well, we know that distance and time are proportional, or miles per hour was proportional because they have the same constant of proportionality. Yes, yes, yes. And then number 4, I am skipping that one. Don't I know. So in today's lesson, to encapsulate everything all together, we had two tables that had the same measurements, centimeters and meters, but one of them was flipped around. So that way it was millimeters and centimeters. You notice that the difference it makes a reciprocal. You have two different constant of proportionalities and they are reciprocals of each other. In this case, it was times 10. And in this case, it was the flip version. It was times 1 over 10 or divide by 10. Both are exactly the same. Yes. And here in this situation, we grabbed our constant of proportionality 550 and said, hey, we can use this constant of proportionality to figure out other distances and other times on our table. So if we have 550, we can multiply that by 1.7 hours to get our miles, 935 miles. We can, since we don't have the time here, we could just say, 330 divided by 550 miles will give us our actual time of 36 minutes. So using the constant of proportionality, we could actually figure out as many values as needed or as much as we want to find. So the relationship between distance and time is proportional because it has a constant of proportionality of times 550. Yes, the unit rate is what helps out a lot, honestly. 550. This is also called the unit rate. There you go. All right, y'all. That's pretty much it. Your homework, you do only have 3 problems. Page 126 to 127, numbers 1, 2, and 3. Do your best. And I think that's pretty much it, y'all. Like and subscribe. Do your best. Any questions, I'm here for y'all. Bye-bye.